Okay, good day IM2 student. Today we will start with our module 6.2 day 1 is on transforming quadratic functions. Content standard. Student will be able to transform a quadratic function by replacing it with positive or negative values. Language objective. Student will work in pairs or small group to both give and listen to oral clue about graphs of quadratic functions. Okay, example 1, understanding vertical translation. That means that the graph is vertical going either up or down. Right? A vertical translation of a parabola is a shift of a parabola up or down with no change in the shape of the parabola. Okay, so the shape remains the same, either the graph going to shift up or down. Vertical translation of a parabola. The graph of the function f of x equal to x squared plus k is a graph of the parent function f of x equal to x squared translated vertically. If k is greater than 0, that means that k is a positive. The graph of the parent function is translated k unit up. If k is less than 0, that means that k is a negative. The graph of the parent function is translated absolute value k unit down. Right, so here is our first example, the graph g of x equal to x squared minus 5. Okay, so which means that we're expecting the graph to translate 5 unit down. Right, so let's go through this. So this is x, and this is our g of x, and it said x squared minus 5. Okay, so our x, so this is x, and this is y. Okay, so then our reference point negative 2, 4, so we have a negative 2, so this gives us negative 2 squared minus 5, so 4 minus 5 gives us a negative 1, and negative 1 we have, okay, so let me change this a little bit, that's a mistake, so we have a negative 1 squared minus 5, so this gives us 1 minus 5 gives us a negative 4, and 0, so we have 0 squared minus 5, so it gives us a negative 5, 1 squared minus 5, so it gives us a negative 4, and 2 squared minus 5, so 4 minus 5, negative 1, so we can go and graph those. So negative 2, negative 1 is here, right, and negative 1, negative 4 is here, and 0, negative 5 is here, and 1, negative 4, right, and 2, negative 1 is here. So then this is our graph. Right, okay, if see the blue is our parent's graph, you notice that the graph shifts 5 unit down. So then absolute value of negative 5 is 5. Okay, let's go on to our next example. So how did the value of in the table g of x equal to x squared plus 2 compare with the value in the table of the parent function? Right, so here we see that the x remain the same, but then the y is 2 unit up. Okay, and then for our example 4, g of x equal to x squared minus 5, the same thing. So x go to our x, and our y go to our new, our minus 5. Come on. Okay. Yeah, so our y goes 5 unit down. Okay, so let's try this one. So you see that this is our x, and this is our g of x equal to x squared plus 4. Right? So then we have a negative 2. So then we have a negative 2 squared plus 4. So 4 plus 4 is 8. Or negative 1, or you can start from here. 1 plus 4, which gives us 5. 0 and 0 plus 4, that gives us a 4. And 1 and 1 plus 4 is a 5 and 2. So you do 2 squared plus 4, or you can start from here. 4 plus 4 gives us 8. So then negative 2 and 8 is here, and negative 1 and 5, negative 1 and 5 is here, and 0 and 4 is here, and 1 and 5 is here, and 2 and 8 is here. So the graph is this. So it went up 4 units, right? And said give the minimum or maximum value and the axis of symmetry. So from our previous lesson, we know that the vertex is 0, 4. So the maximum is y equal to 4, and the axis the axis of symmetry is this line here, which is x equal to 0. So this is our axis of symmetry. Okay, let's go on to our next one. Right. So this is x, and this is x squared minus 7. So negative 2, or you can do 4 minus 7 gives us a negative 3. Negative 1, 1 minus 7 gives us a negative 6. 0, 0 minus 7 gives us a negative 7. 1, 1 minus 7 is negative 6. And 2, 4 minus 7 gives us a negative 3. Right? So we have negative 2 and negative 3 is this point. Negative 1, negative 6. And 0, negative 7. And 1, negative 6. And 2, negative 3. So then this is our graph. Okay, so then the vertex is 0, negative 7. So we have a maximum, y equal to negative 7, and our axis of symmetry, x equal to 0. Right, and then for number 2, example 2, understanding horizontal translations. That means that a horizontal translation of a parabola is a shift of the parabola left or right with no change in the shape of the parabola. The graph of the function f of x equal to the parenthesis x minus x close parenthesis square is the graph of the parent function f of x equal to x squared translated horizontally. If h is greater than 0, okay, so that means that h is a positive, but be careful that the negative is inside the formula already. Right? So the graph f of x squared translate h unit to the right. If h is a negative, that means less than 0, the graph of the function f of x equal to x squared is translated to the left. So if you see something that looks like this, negative h squared, that means that going to the right, and x minus a negative h squared, when it double negative become a plus, so it looks something x plus x squared. That means we shift to the left. Okay? Right. Okay, so then our reference point is going to be now negative 2 plus h, and the k and the y stay the same. Right, so negative 1 plus h, 1, 0 plus h, 0, and 1 plus h. That gives us a 1 and 2 plus h, and that gives us a 4. Right, so now the y value remains the same, the x will change. Okay, so let's try our example. So then graph each quadratic function, give the minimum and maximum value in the axis of symmetry. So we have g of x equal to the quantity of x plus 1 squared. Make a table of value and graph the function together. So notice that our h in this case is a negative 1. Right, so we have a negative 2 minus 1, that gives us a negative 3. 4 remain as a 4. So negative 1 minus 1 gives us negative 2, 1. 0 minus 1 is a negative 1 and 0. So let me make this clear. We have a negative 3 and 4, negative 2 and 1, and -1, 0. So we have 1 minus 1, and 1, so 0, 1, we have a point 0, 1, and here we have 2 minus 1, give us a 1 and a 4, right? So a point 1, 4. So we can graph this. So -3 and 4, this point, -2, 1, this point, and 0, -1, 0, this point, and 0, 1, this point, and 1, 4, this point. So this is our graph. Okay, notice that the graph shifts 1 unit to the left, right? So the blue is our parent's graph. So the graph shifts 1 unit to the left. Okay, and see that they're looking, see the graph open up, so we have the maximum. So the maximum right at the vertex. So then the vertex is 0, -1. My mistake. Let me erase that. So the vertex is -1, 0. So maximum y equal to 0, and the axis of symmetry x equal to -1. Okay, let's go on to our next one. Right, so we see that how does the value of the table g of x equal to quantity of x minus 1 quantity squared compare with the value in the table of the present function. So we see that this one, the value of x shift 1 unit to the left, so then -1, and the value y remain the same. Right? Oh, my mistake, +1. And then this one, that x minus 1, the value y remain the same. Okay, let's go on to our next one. So this is similar to what we just did. So then first identify what h is. So then h is 2. Okay, so there's not enough room here, so I'm going to work this out. So we have a -2 plus 2 is 0. 4, -1 plus 2 is 1. 1, 0 plus 2 is 2, and 0. 1 plus 2 is 3, and 0. And 2 plus 2 is 4, and 4. Right, so we can graph that. 0, 4 is here. 1, 1. So 1, 1 maybe there. And 2, 0 is here. And we said 3, 1, my mistake. There's should be a 1 here. So 3, 1, and 4, 4. So it's here. So the graph gonna do this. Right. So the graph shift 2 units to the right. Okay. So then we set your vertex is 2, 0. So the maximum is at 2, and your axis of symmetry x. My mistake. The maximum is at 0. Axis of symmetry is 2. Right, and for number 10, h is a -3. Okay, so we have 2 minus 3 give us a -5, 4 remains 4, -1, -3 give us a -4, and 4, 0 minus 3, -3, 0. Another mistake. Supposed to be 1, right? 1 minus 3 is a -2, and that gives us the 1. 2 minus 3, -1, and that gives us a 4. Alright, maybe I should give extra credit if you guys can catch my mistake. So -4, -5, and 4, so it's here. Okay, and -4 and 1, so it's here. -3, 0 is here, and -2, 1 is here, and -1, 4. So the graph is this graph, right? So the graph shifts 3 units to the left. So then your maximum. First, let's identify the vertex first. So the vertex is -3 and 0. So your maximum y equal to 0, and your axis of symmetry, so x equal to -3. Right. So here we're given the function for a parabola f of x equal to 2 times the coordinate of x minus 3, coordinate square minus 4. We will complete this. So this is going back to our previous lesson. So the vertex here is, well, first let's do our parameter. So then a is 2, b is 1, h is 3, and k is 4, right? Negative 4, so the vertex is h and k, so then is 3, negative 4. Okay, so then the vertex we set at 3, comma, negative 4, and the graph was an a is a positive, so the graph gonna open upward, right? Okay, and the function has a minimum, well, since it's open upward, the minimum is that the vertex is always this point here, so set y equal to negative 4. Okay. Oops, I've been saying the maximum, so let's change all this to the minimum. My mistake. So this is also the minimum. So let me see where I make other mistakes. So this is also the minimum, not the max. Okay, so let's see where I could make those mistakes. The same here. This is your minimum. So this is also the minimum as well, right? So there's no other mistake, so let's move on. Okay, so here we're giving the parent function and the graph, and we are to write the function for our graph. So first I want you to identify your vertex. So the vertex is this point here, so then it's at 2, negative 2. So that means that our h is going to be 2 and our k is going to be a negative 2. So what is the horizontal translation? So that means that h equal to 2 to the right. And what is the vertical translation? So that k equal to negative 2, so 2 to the down. So what is the quadratic equation of the graph? So we see that g of x, not f of x. So then our g of x is equal to h minus h squared plus k. Right? So then our graph is going to be x minus 2 squared minus 2. Okay, so then here review, right, describe the transformation. So then a is a 3, so we have a vertical stretch, and then our h is a 7, so that the graph shifts to the right, and k equal to negative 8, so the graph shifts down, and a is 4, so then we have a vertical stretch, and h is a negative 5, so the graph shifts to the left. Right? And number 5, k is 3, so the graph going up, and h is 4, so we're going to the right, and k is 3, so the graph going up. And then for number 7, be careful with that. So h is a negative 1, so we're going left. And k is a negative 4, so the graph shift down. Okay. So that's the end of our 6.2 day 1. We have bookwork and HRW. And we need you to copy down 6.2 day 2 notes.